So, talking about Fusion 360, it's actually a 3D modeling software, and in the like what you see in front is the Fusion 360 interface. And today we'll be building this particular model, which has a lot of components, and I have described those components by different colors. The red one, the yellow rod, the handle, and these two screws. So we'll be building this today. And let me explain to you what Fusion 360 is. So Fusion 360 has a lot of workspaces to work with. We are currently in the design software. You can see that on the top left. There are lots of workspaces like design, render, animation, simulation, manufacture, and drawing. You can go through this on your own, but today the most important part is the design workspace where all the magic happens, I would say. And I have all my life used this particular workspace because this is where all the design happens. In render, you actually get to know what it will look practically. In animation, you can use for doing presentations, simulation to get the practical effects of what your product is. That's all the workspaces are there here. And in the design workspace, I would say today we'll be working in the design workspace only. And design workspace has a lot of panels like solid, surface, mesh, sheet metal, plastic, utilities. We'll be working with solid today because I cannot actually teach you all of this today because there's not enough time. And in the solid workspace, I would say there are a lot of tools that you can explore. Uh, so for building this particular product, we have to use the design workspace and come to the solid panel. Now, it is actually set by default when you enter Fusion 360 that you will be in the design workspace and the solid panel because that's where all the building happens at start, and then you can go to other workspaces as well. So starting with creating a design. Before creating a design, anything, we have to first create a sketch for that design. So we have to build these components one by one. The first one I will be building is the red component. And to create a component, first you have to make a sketch of that component and then use that to create a solid out of it or a surface. To create a solid out of it, you will use the solid panel. You create a surface, you can use the surface panel. But to create a solid, I'll be using the solid panel. Now, the first thing you do is to create a sketch. Actually, Fusion 360 wants you to explore each and every tool because when you hover over each and every tool, you will actually see a description of that tool. So I would highly encourage you to just go through all of these. And the first thing is to create sketch. I'll click on create sketch. It gives me option of creating sketch in any of these three planes. Uh, these three planes. So I'll be choosing the horizontal plane and I have to create this first component. Let me hide all of those just by clicking on the I button in the browser. Uh, I'll be just opening this. I have to make this first. So to make this, I can clearly see that I need a base, and to create the base, I have to create a sketch. So we are in the sketch menu, and we have all the types of sketches in the create panel as well. Line, rectangle, circle, arc, any type of sketch. If you are familiar with engineering drawing, then you will know this. So I'll be choosing in the right side. There are three types of rectangles. I've chosen the rectangle. Center rectangle is my favorite one because it requires only the center and another point. So let me build a base like also I would say get down all your measurements first, then start building a project because you can't just keep trial and erroring every time you build anything. So just keep down all the measurements. I know what my measurements are. That's why I'm starting with this. So 100 is the width and 300 is the breadth. Also, if you're not getting the measurements correctly, just click it randomly and click on D. D is actually this tool right there, sketch dimension, and just click on one side. It will show you the dimension and help you edit it as well. So I'll be using 300 mm and the breadth is 100 mm. We have a base with 300 by 100. So this is our first sketch to create this particular component. So let me finish the sketch. So we have our first sketch available in this horizontal plane that we selected. Now the second thing, the first thing is done. The second thing is to make a solid out of that sketch. And how do we do that? By using all of these features from the create panel. The most important one will be extrude. Then there's revolve. Also, you can see what each and everything does by just hovering over it. Hole, hole is not needed for now. Rectangular pattern. There are lots of like thread, box, cylinder. That's all. The most important one I would say would be extrude, which is available at the top. So just click on extrude. What extrude does is it just gives height to a sketch. If you build a sketch in a plane, it's just consider it as an area, and extrude just selects that area and gives height to it. So I'll be giving it some height. As you can see, it creates a solid height. So as well in the solid panel, it will always make a solid. So let me create a height to it. I'll choose 30 mm. That's fine. Also at the right side, each when you click on each feature, it has its own panels at the it has its own features. So at the right, it will show its features and what all it has. For example, it's actually one side now. You can use two sides to extrude two ways, but we only want two sides. We only want one side now. And the most important one is the operation panel. Whenever you go to a feature, I want this to be a component, not a body. So just drag this and click on new component always. If you want to work with some designs, whenever you create a design or product, always make it into a new component unless you have a really good reason to make it into a body. I'll explain why you need to make it into a component, because there are lots of things that you can do with component that you cannot do with a body. So let's click on new component. So we have made a new component which looks like this. So we're getting close to what we're trying to build here. Now I know that there are these two plates here. So let's build these two plates. So to build these two plates, first always we have to start with a sketch. Click on the create sketch feature. Click on this plane. So the property of the sketch is to, you don't need always a plane to actually create a sketch. You can create a sketch on a side of an object as well. So I can create here, I can create here. I want it here now because I want to have those two plates. So I'll be clicking on this plane of that object. I want these two plates. So I know that by logic, they'll be created by creating two rectangles, small rectangles. Uh, 1 second. Yeah, I'll be creating a small rectangle here and symmetrically here, which is I think 10 by 100. Each rectangle is 10 by 100. I'll finish the sketch. Also, you can see that the plane I selected is where the sketches are at. So I'll extrude these two to make these plates. So just click on extrude, click the two sketches that I built and just give them height. So I'll be taking 100 height. I don't need to actually change that. Now this panel, I don't want it to be a new component now. I want to join this feature to this component. So I'll be clicking on joint here. So always remember that this is the most important part of creating a product. So click OK. Now we have those two plates, but we don't have these curves. I want a semicircle out of this. So there are lots of ways to do that. I think the most efficient way would be using a modify feature. So what the modify panel does is modifies the created solids that we create from this panel. Modify features have a lot of features like fillet, chamfer, shell. I'll go through 2 or 3 of them in this session, but I cannot go through all of them. So I'll be using the fillet feature. What fillet feature does is actually makes edges rounded or makes edges circular, I would say. So I'll choose the fillet feature and click on one of the edges. So you can see what the fillet feature does. So the fillet feature makes it rounded or like uh, gives it a circular tone. So I want to make it circular. I know that this is a radius. This particular number is the radius of the circle that you're making at that edge. So I actually know that the edge, this edge, this edge is 100 mm, so the radius should be 50, so that we have to make a semicircle on both edges. So I'll be making 50. All right, we have one edge done. So we don't need to click each and every one of them one by one. So we can click all of them at once. I'll just click this edge, and this edge all at once, and it will do the same thing to all of them. Uh, 50. All of them should be 50, because that's what will make it a semicircle. So yeah, okay. We have the rounded edges for this plate. Now now we have to make holes in these. So the best feature to make a hole is to just use this uh, hole command H. You can call that by H key as well, but I'll be clicking on that. So let's click on hole. What hole does is just finds a surface and creates a hole in it. That's all. So I'll be clicking this surface, and as you can see, it has its default size of the hole and default height of the hole as well. So the red thing actually signifies that it's actually cutting through the solid. So what I have to do is just uh, give its radius. I want the radius to be 50. So yeah. Also, one important thing, we have something at the top right. We call it, I don't know what we call that, but it's actually a good representation of the space we are in. If you touch that cube and drag it the way you like, it will actually orbit it around the product that you want. But there's actually another way to orbit as well. Just click on the shift key and click on the middle mouse button to just orbit. Just place your cursor anywhere, click on shift key and click on middle mouse button to orbit the product and see from different perspectives. Now, what I need to do is place the hole where I want. So I'll go to the top view. As you can see, there's a top view here written at the top right. Go to the top view. I want the hole to be at the center of this side. So Fusion 360 has a feature to automatically detect symmetricity. So it has automatically detected the center with the white point. So I'll be placing that there. And I've already set the radius, and it actually is cutting through the solid. So I don't need to do anything. Okay. Yeah, I've created a hole here. Now I'll do the same thing here by clicking on hole, clicking on this side, going to the top, and it's actually set to 15 only. Yeah, 15 radius only. 15 radius, it's actually 15 diameter. Okay, 15 diameter. So it's actually set, so I don't need to do anything. Is it in the middle? Let me check. Yeah, it's in the middle. So let's click OK. So we have these two here, these two holes done. Now I want these two holes. So yeah, the same thing, but I'll do it in a different way. There are two ways to build a hole. I'll say the one is the using the hole feature, which is the easiest one. One is using the extrude feature. Extrude feature is what we used earlier. Just click on create sketch. I'll be creating sketch on this plane. I'll be making a circle and extruding it inwards, not outwards, so that it will actually cut through the plane, cut through the plates and not actually build. So extrude can also do that. Extrude can also cut through. So the best part is it's not particularly a circle. You can make it like any shape, any type of hole you want. So I'll be selecting this plane. I'll use a circle in the middle. It automatically detects the semicircle's center because it has a smart feature. I'll be building a circle with radius of 30. Okay, finish sketch. Now we have a sketch in this plane. I'll be clicking the extrude command, selecting this extrude, extruding this, not outward. Outward will create a solid. I'll do it inwards, and due to its smart feature, it will actually cut through. And as you can see, it will not join, it will be cutting. So it automatically detects that operation. So I'll click OK because it has went through the two holes. Okay. So these are the two ways to you can actually make a hole or anything like that in a solid block. Now we have the first component ready. but one thing is missing, that is coloring. So the best way to color a component in Fusion 360 is to just give it an appearance. That can be done by clicking A on the keyboard. Remember, you have to click A, which is the appearance tab that will give color on any type of material to this product or this component. So I'll click A on the keyboard. I have the appearance panel here. Now, by default, it's still satin. The material is still satin, but there are lots of materials that you can give to this. I love to give it paint. So whatever the material be, paint gives it a similar texture. So I want to give it the red glossy paint. So I'll just drag this paint to this component. So yeah, I have the I have the component color. Close. Now we have the first component ready. We have to jump to the second component, which is this rod. So yeah, this rod is yellow, and we have this actually looks pretty easy. Uh, it's not that hard. So what you have to do, we can just build it besides this, and let's see. I'll create a sketch. I'll choose this plane, this vertical plane, not the horizontal plane this time, because I know that the rod is horizontal and I have to extrude it. So I'll be using circle. I know that this will go through this, and its radius is actually 30, or what's its radius? Around 30. Not 30. Its radius is 15. Its diameter is 30. Okay. So I'll be making it somewhere here, around 30 diameter. So I have my sketch, finished sketch. So yeah, I have my sketch here. I'll just extrude that sketch. Also, last time I did one side, I'll do two sides now. Remember, there are many features in a feature as well. So it's symmetric or two sides. I want it to be symmetric, but I have to explain you two sides as well. Symmetric means it will extend both ways by the same margin. So I'll use two sides now. So actually I can extend it two sides. I can give it height two sides from that sketch. I want it to be 100. So it's 100 here, 100 here. So yeah, it's done. I have to create a new component. Always remember, not new body, new component. Okay. Yeah. Also, as you can see at the bottom, there is a timeline of all the events that occurred when I was making this product. So if you want to go back in time and see what you did at that time, you can just drag this pointer backwards and see what you did and when you did use that feature. It's actually a timeline of the events that occurred. So yeah, if you want to edit a feature that you did earlier, just go to that feature and right click and edit that feature. That's all you need to do. If I want to edit this extrude feature, I'll go to the timeline and click on that feature. When I did that feature, edit feature, then I can change that feature according to my satisfaction. So yeah, not new body, cancel. I want to do a component. So we have two components, component one, component two in the browser. So now the rod is made, the main part of the rod is made. We have to create these two bumps as well so that it will be locked inside. It will be locked between these. Now uh, I have to create another sketch in the vertical plane so that I can make these two bumps. I'll click on this plane, or else I'll not do this. Okay. Or else I can just go to this feature in the timeline and edit that feature. So we have this sketch. This sketch is not visible. Just go to the browser. It's actually checked off. One second. Yeah, it's actually checked off. Yeah, you can see the sketch now. Okay, just close it. Now we can see the sketch. I'll build a new sketch around that. Go to the front. I'll create another circle with, I think, 40 or 50 50, yeah, 50 is fine, 50 diameter. Yeah, we have two circles in that particular plane, and we have successfully edited the sketch that we built earlier. Now, finish sketch. Now I'll be showing you how you can actually manipulate the extrude command. I actually use this a lot. I'll click on extrude. I'll choose this. One second. One second. I did some mistake. One second. Hmm. I'll go to the sketch. One second. Yeah, the other two circles. I'll extrude this part. So it automatically detects like which part you want to extrude. I don't want the inner part to be extruded. I want the outer part, the circle, like the part between those two circles. So now I'll choose two sides and extrude it. I have these two pointers. I can drag it anywhere I like. So I want this to go somewhere here, but it's so the best thing about no matter where the sketch is, you can actually place the extrude anywhere you like. I want this to be here. So just to create these two bumps, I will use just one sketch. So uh, it's actually set to join. So I'll click OK. So we have our first bump, uh, and then I'll create a second bump on the other side. Go to the right side and click on two sides. I'll go this way and this way. Join. Okay, it's done. Yeah, we have the two bumps. I'll hide this sketch. Now the only thing remaining for this particular component is to called chamfer. Chamfer is quite actually related to fillet, which is a modification feature. It's actually related to fillet. Chamfer just makes it round. Fillet just makes it round. Chamfer just gives it an extra edge. That's all. I'll select chamfer. I'll select this edge, and as you can see, it just one second. Chamfer this edge as an arrow available. Just give an edge to that. So I'll be giving around 15 mm. So 15 mm looks fine. Okay. The same thing I'll do with this edge. Chamfer. 15 mm. I'll just type it. Yeah. We have our second component available, but the color is, I think, yellow. So yeah, click on A for appearance. I'll choose the yellow paint and drag it to the component. Close. So we have our two components available. Now the third component is the handle that we have to place, the green handle. So to make the handle, let me hide these two components. Let me show how the handle looks. So yeah, I'll be creating the handle at the right side of this. So let me go to the horizontal component. Yeah. So for the handle, I need to make a base, then extrude it, then create these two plates that I did earlier. And I can create a sketch for this as well. So use a rectangle, center point rectangle. I have also remember the dimensions need to be precise. So I know my dimensions, that's why I'm drawing it pretty fast. Always note down your dimensions, all right? So this sketch is 100 by, I think, it was 150. 100 to 150, 160. Yeah, it was 100 by 160. Okay, we have the base and sketch. I'll be extruding this upwards by 20, not 20, 15 is fine. Yeah, 15 is fine. Create a new component, always remember. Okay, I'll be creating these two plates similar to this. So we all know how we do that. Uh, we can use this 10 by 100. Second rectangle will be also 10 by 100. 10 by 100. You can see it's 100, not 100. One second. It's 100. I think I created the sketch. One second. Ah, I made the dimensions wrong, I think. I'll go to the sketch in the timeline and click on that sketch. Make that sketch visible. Yeah, I have to edit this sketch because I got the dimensions wrong. I have 160. Click on D. Check the dimensions. It's actually 109. So I want it to be 100. Finish sketch. Now I think when you go into the future with the timeline, you'll get this. Yeah, this extrude. Now we can make the sketch. Create sketch on this plane. 100 by 10. Yes, 100 by 10. Yeah. Finish sketch. We have done this before, that's why I'm doing it pretty fast. 1, 2, then extrude this upwards by 100, I think. Yeah, join. Okay. I have something here. One second. Let me go to this sketch again. Edit this sketch. Yeah, the dimensions are not right here. Right. Yeah. Okay. You can see how I use the timeline pretty well. So yeah, we have applets. Now we'll apply the fillet command, fillet modification. Click 1, 2, 3, 4. 50 radius. It's actually detected 50. Okay. I'll create a hole. I'll just directly use the hole. I'll go to the front view and I'll place it at the center. And the radius is, I think, 30. No, yeah, not the radius, the diameter. Okay. Yeah, the hole is not quite long, so I'll edit the feature. I'll drag this hole and make it go through the other side. Okay. So we have our base, we have this part of the component ready. Now we just need the handle. So it's quite easy. Just go to the bottom, create a sketch on this plane. Now we'll build a circle around this. By symmetricity, it actually detects symmetric. Yeah, I think 40 is enough. 40 is enough. 40 diameter. Finish sketch. We'll choose this, extrude this by, I think 100 is enough. Join, it will be joined to this component. Don't forget to join, okay? Now we have to fillet this edge. Just do it on your own convenience. So yeah, this component is done. I'll be just coloring it with green. Go to A, press A on your keyboard. I'll be giving it color green. Close. So yeah, we have 3 components done. Now what we need is, the last thing is to build screws. These 2 screws. So you'll be learning another 2 features with this. So all the components look like this. We just need these 2 screws. So let me hide this component. Yeah, we just need these 2 screws. So just to create these 2 screws, you'll be learning more features like threading and revolve. Now just again the same thing. Go to create sketch, select the horizontal plane. Uh, we have the circle. As far as I remember, this radius is 15. So I'll be making a circle with radius 15. Finish. Extrude it below. By the height of this component was, I think, 30. So let me make it 30. New component, always remember, new component, not new body. Okay. Yeah. We have this part of the screw. Now we need to make the cap. We need to make this cap. So I'll be using another feature for this called the revolve. So I have to make a sketch here. 1 second. Let me show you what revolve does. Revolve actually takes a sketch and makes it revolve around an axis and makes it into a solid. So you can actually see where I'm going with this. So let me just make a plane here. 1 second. Create sketch. I want a sketch to be symmetric to this in this plane. So how do I make a plane come here? So I'll be teaching you a new feature called offset plane. So I'll click on the offset plane. What offset plane actually does is it takes a plane and like offsets it obviously. So for example, let me click on offset plane. I'll click on this plane and it make a small plane. So I can actually drag this plane to make new sketches wherever I like. But this plane is not according to my convenience. I want it to be perpendicular vertical sketch. So cancel. So apart from offset plane, there's also one feature called plane at an angle. So this is a plane. This actually what actually does is it rotates the plane that we offsetted. So let me click on offset plane. I'll click on this plane and take it somewhere here. Okay. Now I'll click on plane at angle. So I'll just click a line. 1 second. Plane angle. Okay. This is not working. One second. Let's forget this. I'll offset not this plane. Let me delete this plane. Let me delete this plane. I'll offset the main plane, main vertical plane here. So let me go to the front view to see it clearly. I want this plane to be in the middle, and it actually sets it into the middle. So I don't need to worry about anything. Okay. So we have a plane. We have a plane that we can draw a sketch on. So click OK. Click on the create sketch and select this plane. I'll be building just this part of the screw cap and will revolve it throughout this axis. So let me create a line from the middle to somewhere, I would say 20 or 15. Yeah, 15. And I'll create a line from here to 10. Now I want an arc to go through this to this. So there's a feature in the create. When you create a sketch, there are lots of things you can do. I've used 2-point rectangle, circle. So there's line as well. Fit point as spline. Spline actually is a curved line. You can mirror the sketch the way you want. You can sketch dimension, which is actually called by D. And there's circle, there's all types of ellipses. So I'll be using the arc, and it actually gives me three options: 3-point arc, center point arc, tangent arc. I'll be using 3-point arc. So what it does is I have to click 3 times to get an arc. So once again, first point, not here. Once again, go to arc 3 point, 1, 2, and 3. Yeah, this is how you can make an arc. So I want this to be around, let's say here, not here, not here. 3-point arc, 1, 2. Just the 2 points, and the third point is just to place the arc. So I want this here. Okay, this looks pretty good. Now I've made the sketch. It looks like this. So what I'll do is I'll revolve this sketch, not extrude. I'll revolve this sketch by clicking on revolve. I have the plane already selected. Let me unselect. I'll select the profile. The second selection is the axis. So the axis should be this. So it automatically revolves around 360 degrees. You can see how it works. So I'll do it 360. Join it. It's actually joined to the component that we're building it on, and that's all. Okay. So we have the cap, we have the bottom, we have everything available. Now the next thing would be the chamfer at the bottom. So just click on chamfer, click on this, and just uh, drag it. It is according to your convenience how much you want to do it. So I'll do it 7.5. Yeah. Now we have the basic sketch available, basic model of a screw available, but we want a plus to be here as well. So the next thing I would say is I want a plane here at the top. The plane should be, I think, here horizontally, so that I can make a plus and extrude it inward so that I can cut a plus through it. So let me offset a plane. I'll choose this horizontal plane and make it go through some, I think this is pretty good. Okay, so we have a plane here. I'll choose this plane and make a sketch here. which is a plus. So it actually, uh, 1 second. It looks like 24. You can have your own shape. It depends on you. I have to create 1 second. Yeah, this is pretty fine. 24 by 4. Okay. Now I'll create another 24 by 4. Okay. Finish sketch. So as you can see, we have a sketch at the top. All we have to do is just extrude it inwards and cut through this. So I'll just choose all of this and extrude it inwards. Yeah, it automatically detects if it cuts through a solid. So it is cutting. Yeah, this is enough. This is enough. Or we can go through more. Yeah, okay. Cut. So we have our screw available now. We have our screw. Yeah. The last thing remaining is to give a threading to this screw. So we have another feature called thread, which actually just gives a threading of a screw to a surface. That's all. Just click on thread, just select the face, and it will just give a threading to it. You can customize it, but I'll just leave it like that only. Okay. So that's the threading feature and the revolve feature to make a screw. But you can see that we have two screws available here. So you can use a feature of mirroring a component, or I would love to see that you use a rectangular pattern for this, because rectangular pattern is just duplicating a component by m by n. That's all it does. So I'll click on rectangular pattern. I'll choose components because we are working with components. I'll select this object. Directions, I would say directions are given by these three axes. So I want the direction to be this way. So I'll create not two. I want it to be not three. I want it to be two. So as you can see, actually creates a pattern, M by N pattern. So I don't want it to go this way. I want it only this way, only one. So quantity here one, and this way quantity two. So 1 by 2. Rectangular pattern is this. So we have two components here, two screws. At last, we have all the components available for our design. So all we need to do is just join them. Now we come to the next part of Fusion 360. This is all just creating and designing. The next crucial part of Fusion 360 or 3D modeling or anything related to mechanics is joints. Let me explain to you what joints really is. 1 second. Joints is actually the main definition is written here. Joint is used to allow a certain type of relative motion between two components it connects. A joint is a global feature that needs two attachments, one from each component. One attachment attacks as a source and one other as a destination. This is a complex definition. I would say in mechanics, joints are actually just constraints between two components. uh, they are constrained by two components and that are governed by just degrees of freedom between these two. So let me show you what other types of joints are there. First one is the prismatic joint. Prismatic joint is just two components that have one translational degree of freedom. That's all. You can see that it can only move in one direction translationally. No rotational degree of freedom. We all know that there are three rotational degrees of freedom and three translational degrees of freedom. So just two components constrained with each other by a joint at a point. The point is here or anywhere they like. So the prismatic joint, hinge joint is just one rotational degree of freedom. The 1 second. How can I hide this? This hinge joint, and then 1 second. There are lots of joints like this: hinge joint, cylindrical joint, and cylindrical joint is just 2 degrees of freedom. For example, let me show you. Where was I? Uh, cylindrical joint. Cylindrical joint is just this one with one rotational degree of freedom. So the cylinder can rotate, and one translational degree of freedom. Now there's also fixed joint, which means there is no degree of freedom, no rotational, no translation. It's actually just a rigid joint. So uh, we have to join these components through these different types of joints. Uh, you have to guess what these type of joints are. So before joining all these components, let me tell you the most important thing. The first thing you need to do is to ground a component that will I that you should be sure that will not move at all. So I know that this red base will not move at all throughout this. So I'll just click on this component, right click on this component and ground it. Always remember ground one component before starting to join all these components. So ground it. It will actually show a label with pin so that you can actually not move it. If there's a component, you can actually move it any way you like. Just click on that component and move it. But if you ground it, you cannot actually move it because it's constrained to be there. So yeah. I'll just click on revert position. That's capture position and revert position. Revert means go back to the original position. So always click on revert position for symmetricity. Yeah. Now I know that this component will be joined, and they will be joined by the rotation, the hinge joint, because the yellow component will only have a rotational degree of freedom to move because of the joint. It's just logical. So let me click on joints. The joint is there in the assemble section, and this is the most important feature of mechanics, I think. Like for now, it's the most important feature. Click on joints. As you can see, this one is actually faded because the grounded component cannot actually move. And in the joint feature, we have to select two components. Component one that has to be joined to component two. So we have to select one by one. So by default, the component one that you select will go to component two. It will move to component two. So by default, we have actually grounded this component. No, so it cannot actually not move. So it will fade away during the first selection. So let me select this. Also, always remember joint feature. There are 2 points. The first point will be on the first component. The second point will be given to the second component. And always remember those 2 points will align. That's all the joint component is. So let me give the pointer to this edge. You can see the pointer by these three axes in between. I'll get this pointer to this edge. And now I'll select what that pointer will align to. I know that this edge will align to this edge, this edge. So these 2 points will align. You can see clearly that those two pointers will align themselves in joints. And by default, they have been selected by, they have been joined by rigid joint. So rigid joint is actually just, let me show you its animation. It actually shows that they will not move with respect to each other. No degree of freedom. But we want it to be revolute. So it's actually rotating around this axis. You can change the axis, but by practical means, I think the Z axis is practical. So it will look like this. I wanted to rotate around this axis with one degree of freedom with the revolute joint. That's all. Revolute is actually the hinge joint. So okay, I'm satisfied with this joint. Okay. Now now I want to join this green joint to the yellow joint, yellow component. So all I need to do is click on joint. The by default, now the revolute joint is selected. Just you need to know like which edge will be aligned to which edge. So I'll click on this edge, and this will create a pointer on the first component, and the second component is here. Let me drag it a little bit towards the middle, or let it be here. So yeah, the revolute joint is done. Okay, we all know that this will be a revolute joint as well as a cylindrical joint, because let me do the cylindrical joint on this. Let me change the joint cylindrical. Cylindrical is just 2 degrees of freedom, rotational and translational. I know that practically it will be cylindrical joint, but that's actually really complex to give limits to the joint. So I'll be just leaving it a revolute joint, not a cylindrical. You can see all the types of joints, pin slot. You can see that what all degrees of freedom it has. Planar. Planar is actually around like two components uh, having, I think, across a plane, they have a degree of freedom. Also ball. Ball is actually, let me show you. Ball joint is actually this type of joint. You have actually, I think you might have seen this joint in your life. It's a joint between your hip bone as well. So it has three rotational degrees of freedom. So that's what the ball joint is. Let me select the ball joint again. Let me do the animation. Yeah, you can see the animation. Always remember those 2 points that you selected will get aligned and the joint will be around that. Always remember. But due to practical reasons, we know that this will be a revolute joint. So just click on revolute. Okay. It will go through the component. Just it doesn't matter because it's a software. So okay. Now I'll leave it here. We have two joints done. Now we want this to go here, this to go here. And we know by practical means, these two will be rigid to this. This will not move with respect to each other. Or, or you can do, what you can do is align these two, just align. There's also a feature called align in this. One second. In modify, a feature called align, but what it actually does is just aligns it, not joins it. So you want to join it. So just click, we know that this edge, particular edge will be aligned to this particular edge. That's just logical. So it will actually align these two components. Uh, it actually detected it to be a revolute joint, but we want it to be rigid. We know it will revolve, but just rigid is enough. Okay. Now the last joint needed is the rigid joint of the screw and will be done. Click on joint, this one, this edge. Always remember that those 2 points will align somehow. You can move the joint as well with this arrow, but we don't need that. So well, I'll put it to 0. Okay. Yeah. So finally we have our component ready. We have everything ready. We have all the joints done. What joint actually does is it actually constrains it. So you can drag the feature that you have. So we have created the product that we had here. So yeah, I hope that you all understood what I explained, and the next part will be done by Anish, who is a core member of Team Sahaay, the Social Innovation Club. Then okay, thank you. One second. Hello, Anish.
Yes.
Okay, thank you.
So you can start sharing. So does anyone have any doubts related to this part? Whatever Pranav explained, are there any doubts related to this? If not, I will move forward. So if there aren't any doubts, I will just move forward with the session. So now I will just show one model just to show more things about joints, and after that we will go into the details of automatic waste segregator and try to design one part of the automatic waste segregator using Fusion 360. I will share my screen. So is my screen visible? Can
Yes,
anyone?
yes.
Okay, okay. Yes. So So first we have this, just to explain more about joints. So this mechanism here is called as a crank slider mechanism. Basically, it converts a rotatory motion of this disc into a linear motion of this piston. So here also we have different kinds of joints. So in this model, we have used this is the symbol for a revolute joint, and this is a sliding joint. So sliding joint or a prismatic joint. So I will just show you how these can interact. So if I try to animate this model, if I just mm, move one joint, so this one, so right click and go to animate joint, it will show the motion of this joint. So basically this model has six components. So we go through the components just one by one. So this is a disk. The rotatory motion of this disk will be converted to the linear motion of the piston. Then this is just a shaft around which the disk will rotate. And then we have this another shaft which will connect the disk to the piston. Then these two components are the components of the piston, and it will connect the shaft to the piston from inside like this. And then we have some kind of a cylinder inside which the piston can uh, translate. So as you can see, there are five joints in here. So four of them are revolute joints and one is a sliding joint. So revolute joint, as you know, has 1 degree of freedom, which is a rotational degree of freedom around that axis. And similarly, this sliding joint will have 1 degree of freedom, which will be a translational degree of freedom. So all of these are revolute joints. So the components will just rotate around each other. And this sliding joint is between the piston and the cylinder, so that the cylinder is constrained to move only forward and backward, like in a linear motion inside the cylinder. So by right clicking on any of the joint, you can go to animate joint. So it will show the animation of each of the model, each of the joint. And if you right click on any of it and go to animate model, it will actually animate the whole thing, taking into consideration all the components. So now if I go to animate model, all the joints will work together. So as you can see now, all the joints are into play and everything is working at the same time. So this is rotating around this, then this part is rotating around the shaft, and this is moving forward and backward. So this was just to show some more things that can be done with joints and about the sliding joint. So now we will just close this. And now we'll come to the automatic waste segregator. So last time we had discussed about the mechanical design of the automatic waste segregator. So we will try to replicate this thing. So this is just a basic frame of the automatic waste segregator. We will try to build this in today's session. So as you can see, there are four compartments in the waste segregator for each of the waste category. Then you have this 3/4 disc, and you have this brush which will sweep the waste into each of the compartment. And we also have one motor here which will control the 3/4 disc. So, and one more thing is that this is not a final design of the product. Here we are just trying to learn about Fusion 360 and the different features in Fusion 360, different tools in Fusion 360. And again, so this is not a final product. This is just some part of it, which I will try to replicate today. So let me open a new file. Okay. And one more thing is that the to emphasize is that now this is a actual product which you want to build. Earlier we just had something as an illustrative model to just show the features of Fusion 360. But now it is really important to get your dimensions listed out before you start. So first of all, you have to have all the dimensions of the product, and only then you can go on to create a 3D model for that. So with me, I have listed all the dimensions which I will be referring to while building the model. And so basically for this kind of a product, it is not very important. The 3D model is not that important because at the end we will have to build this thing from scratch using like wood, metal, plastic, those kinds of materials on our own. So this model, maybe it will help us to understand the final product a bit more, or some any physical constraints which will arise while assembling the model that can be understood through this design. And it can be used for representative purposes, just to show in some presentation, or so that people can understand what the product is when we have still not built it. So it need not be very detailed. It can be a rough thing, and things can be added to it later when we are actually building it. But in case we want to build a product, for example, we want to 3D print it. So at that time, the design should be more detailed than this. So let's get started with the design of this. So as you can see, we have one, two, three, four, and five components. So the first component is this frame. First, we will start by making this in a new file. So now you must be pretty familiar with what are the different tools in Fusion 360 as Pranav explained. Most of the times only those tools are required unless you have some specific requirement where some special tool is required. But in general, he has covered most of the things that you will require in Fusion 360. Also, one point I wanted to highlight is that Fusion 360 is a thing that you cannot learn by just watching some tutorials or watching what I am showing here. Until and unless you open Fusion 360 and try to do things on your own, you won't get a feel for it. So the purpose of these sessions is just to familiarize you with the Fusion 360 workspace and tools. But at the end, if you really want to learn Fusion 360, you just have to download it, open it, and start exploring it on your own. Try to make some designs. If you get stuck, you can just search it up on the internet. You get whatever resources you want, like answers to any of the questions which you want will be available on the internet, and then proceed. So that is the, I think, process of learning Fusion 360 is like you have to explore the tool on your own. So, so let's get started with this design. So I'll create a sketch in this horizontal plane. So for the base, I will make a square of 45 centimeter by 45 centimeter. So in the earlier design, we were working in millimeter units. Now we have, as this is going to be a real size model, we will work in centimeter units here. So I have created a square of 45 by 45. Then for each of the pillars or the frame, I will have four squares of 3 centimeter by 3 centimeter. So that also I will create using this 2-point rectangle. So now I will create another rectangle which will be inside this. So by choosing these two corners, so I have one outer rectangle of 45 by 45, and this inner one will be 39 by 39. So 3 centimeters here and 3 centimeters here. So 45 minus 6, this will be 39 centimeter length of this side. So now we can finish this sketch. Now we need to extrude it to create components. So we'll select all of these things. And to select multiple things at time, you just need to, you can hold down the control key and select everything. Right click and extrude. So I want it to have a thickness of 2 mm. The base should 2 centimeter. The base should have a thickness of 2 centimeter, and we'll go to new component. As Pranav said, you need to create components and not bodies, because at the end joints can be created between components and not bodies, and to create a final assembly you need joints. So every time you are creating something, you need to make sure that you are making a new component and not a new body. And inside components you can have multiple bodies, so like you can say body is a subset of components. So you can create a new so inside this component you can see bodies. So right now we have only one body, but we can add multiple if it is required. So now we have created this. We just now we need to create the four pillar kind of things. So I will just hide this. Go to extrude. Then I will select these four squares on the corners. Just unhide this now. I want to give it a height of 77 centimeters. So now by default it is saying the operation, it is showing the operation as cut. But we don't want to cut it. We just want to join the two components into one single component. So I will join it and press OK. And I will just hide the sketch now. So we have this part is done now. Now what we will do is we will create these bars at the top to close it up. So for that, what we can do is create sketches on this plane and this plane and just extrude them to join everything. So I will create a sketch on this plane. So again I will create a 3 by 3 square, 3 centimeter by 3 centimeter square. Finish sketch. Similarly, I will make a sketch on this side. So we can not only make sketches on the X, Y, Y, Z and X, Z, those three planes, you can make it on any face of anybody, as Pranav said. Finish sketch. So now we'll make two similar sketches on the diagonally opposite pillar, so that then we can join everything. So now we need to extrude all these things to join it up. So I will just select extrude, select this face and extend it. So again, I don't want to cut it, I just want to join it. So okay. Again, I will extrude this face, join. Okay. Join. The last one. Okay. So now we have this outer frame for the automatic waste segregator. So now compared to this, now we need to build these four compartments or the four categories of the waste. So for that, what we will do is we will create a new sketch and then extrude it. So I do this component, create sketch, and select this horizontal plane. Okay. So again, we'll create a rectangle of the same dimensions, 45 by 45 centimeter. So now we need a kind of a plus shape in between inside the rectangle on its center, and so that we can extrude it to create the four components. So what we can do is, so we need to find the center of this. So I think this is by default prompting us the center of this square. So if I just move my cursor around, I give to the symmetry, it shows me this is the center. So I can just create a plus sign first here. So now so now as we as Pranav showed the offset plane feature, we can do a similar thing in sketches. So now we need to give some thickness to this plus sign, right? So we will use the offset feature now. We go to offset, we'll select this and this face, and just by sliding this you can like offset it by some distance so that now it can get some thickness. Okay, just a minute, I think this line is a bit, it's not straight, I need to change it. I guess this time it feels it's slanted. I don't know, maybe it was not, but still. Okay, so we'll continue with the offset thing now. So we'll select these two lines, and then if you drag this slider, it will offset both of those lines by some distance. So we want it to be say 0.5 centimeter, or let's say 1 centimeter, and we want it in the opposite direction, so minus 1 centimeter. Okay. Now we'll do the same thing on this side. So offset, select this and this, then enter 1 centimeter. And now we want to create the same thing here also. So now we can use the mirror option. So we have this mirror option here. We can select all four of these lines as the lines to be mirrored, and for the mirror line we will select this horizontal line. So you can see it as it will get mirrored like this. Okay, so now we have this thing. We need to extrude this plus sign. So before that, like now we do not need the line passing through the center, so we can trim it off. So there is an option called trim. We go and we can just select these parts, and now we have this thing. So we can finish the sketch. Now we can select this extrude and extrude this part. For the height of this, the dimension is 57 centimeter. Will this is creating a new body. We don't want that. We want to join it to the first component. So we'll go and select join. So it is getting joined into a single component. Okay. So now you can see that we have this first component ready with us. I'll just save this thing before going from. So are there any doubts till now? Anything related to this? Or else I will just go forward with the next component. I'll just move on with the next component here. So the next component is this thing, which will like be present here. So will just act as a guide for the 3-4 disk which we discussed about. The 3-4 disk which will help to segregate the waste. So this will kind of act as a guide to place that circle, that disk. So we'll go here. For this also we'll try to create another sketch and then extrude it to create that component. So what we can do is that the sketch for that will be similar to this, just there will be one circle here and we will extrude different faces. So we can copy this sketch and create a new sketch using that copy. So if I select all of this, right click and click on copy, then go to, then hide this sketch, create a new sketch and just paste it. I will get the sketch here. So okay, I don't want it to be anywhere else, so I need to move it. So now what I can do is that again uh, create a circle at the center of this. So right now I'm not finding the center of this square directly. So for that what I can do is that we'll just take one line and like draw the diagonal of this. And now when I move across the diagonal, so for example using a circle, so I'm getting by default I'm getting prompted to this point where there is a triangle above the cursor. So this means that this is the midpoint of the line. So we want to create the circle with that center, and the diameter should be 39 centimeter. You can see at 39 centimeter it is tangential to the inner square which we took. So 39. Okay. So now like if you can see this shape, so from that sketch we will try to uh, create this shape. So for that we need to trim some of the parts. So we'll go to trim. We don't need this line now, so we'll just trim it off. Then we don't require this inner square anymore. And we also do not require these parts uh, of the outer square. So we just trim all of these things till we get the required shape. So now we have a shape like this. So we can finish the sketch, and now we can extrude it and give it a thickness of 1.5 centimeters. Okay, so by mistake I have created a body here. So what I can do is there are two options. I can right click on this body and select create components from body, or else what I can do is that I can from the timeline I can select this extrude feature, right click and go to edit feature, and here operation, in operation I can should be able to select new component. So I'm not getting that option. So instead of that I will just go into bodies and create components from body. So now this is a component. So we have our two components. So the third component is actually this 3/4 disk. So creating that is very easy. You just need to create a circle, and so for that I will create the sketch on this component itself. So I will go to create sketch, select this. Now go to circle. So here now when I move my cursor around, I am directly prompted to this point, which is the center of the circle. We want to just trace the same circle once again. Then go to line. Yes, two lines like this. Now if I hide this component, we have this sketch. So now we need to trim this portion to get the 3/4 circle. So now we have this. We can finish the sketch and extrude this part. Again we will have the thickness as 1.5 centimeter. Okay, so now we have these components ready. Okay, so another mistake which I have made is again I have created a body. So we'll just go and create components from body. So now we have our three components. So first I will hide this component. Let's see these two. So right now this second component is at the bottom. So we need to actually move it to the top. We'll right click on it. Go to move and copy. And so I can move it in all the three directions. I can even rotate it around any of the axes. So right now I just want to move it upwards. I will do this thing. I will just first I will move it to an arbitrary position. Then click OK. So according to the dimensions decided, I want to have this part at a distance of 45 centimeter from this plane. So these two planes should have a distance of 45, sorry, not 45, 4.5 centimeter. So for that, what I will do is first I will align these two planes and then move it upwards by 4.5 centimeters. So I will go to modify, uh, align, select this plane, then select this plane. Selected the center properly. Let me do it for long. Now selected this plane and I will select the center of this plane. The corner thing. So now it has been aligned, and now I need to move this component upwards by 4.5 centimeters. So the Z distance I will set it to 4.5 centimeters. Okay. So now this component is in the position I want. So for the disk we will align it later. So I'll hide this also. So now the next thing we need to do is place this motor here. So this will basically be the motor. It will be connected to this thing, this plane. It will be attached here, and it will rotate the 3/4 plane. So it will 3/4 circle. So it will control that motion based on the inputs which it gets from the motor controller. So that will be covered in the electronics part. So basically the output from the image recognition will go into the electrical part, from where the this motor will get the input, where by how many degrees it should move. So okay, so for that we actually, for such motors and standard components, we can directly get those designs, download those designs from any websites online. So I have done that only. So I have in my files, I have this stepper motor file here. So I will just right click on it and go to insert into current design. So you can see the motor has been imported into our design. So now I want to align this motor onto this at the midpoint of this thing. For now I will not move it. Then I will go to modify, go to align. I will select this bottom face and then select the center of this. So now the motor is aligned, but it is pointing in an opposite direction. We want it to point upward, so I can just click on flip, and now it is done properly. So I will click on OK. So now the motor is also in position. Now we need to position our 3/4 disk and create a hole in the disk for the shaft to go in. So we will do that part now. We'll hide the other components, just these two. So first of all, I will just move this component by some random distance so that it is just okay. Take this above this thing just by some random distance. Now what I can do is that I need to create a hole here so that this shaft can fit perfectly into this and it can rotate. For that I will extrude this face and just cut our disk using that profile. So I will go to extrude and capture position, select this face, go upward, so it will cut it by default. So I will click on OK. So now as you can see, this thing as a whole according to this dimension. So this will fit into it properly and then it will rotate. So now I need to align these two things. And not only align, we need to create a revolute joint between them. So joint will also at the same time it will align the two bodies and create a constraint of motion in between them. So I will go into assemble and go into join. So first I will select this part and then I will select this. Okay, so right now it has by automatically set itself to sliding joint, so we don't want that. We want the revolute joint. So yes, this is how we want this to rotate. Animate it. Click OK. And now if I unhide all the other components, you can see that it the disk has gotten aligned properly with the other components as well. So now we need to create the this component, which is the sweeping kind of thing, which will push the waste inside the correct bin once it has been detected. So okay, for that we can create a plane on we can create a sketch on this face of this component. So I will hide the other component, create sketch on top of this. Now I will, here also I can automatically detect the center of the circle. I will first create this circle and then select the center of the circle. Draw one straight line. Chill. Draw. Make sure I'm selecting the center of the circle while starting with one. So 90 degrees on this. Okay. So now we need to give some thickness to this as well. So again, we will use the offset feature. So I will click on it, select these two lines. The thickness I want it to be 1.5 centimeter. Click on enter. Finish this sketch. So now what I can do is that I hide this component from here. Extrude. Click on extrude and just extrude this by 0.8 centimeter is the line position which I want. Okay. And now, okay, so here you can see that it has not been extruded properly. So I can go to edit feature and I will select this face also. So now it is, and I will just join. So again, I have created a body. I create a component. So yes, now this thing is designed. So now this is exactly on top of our disk. So we can separate it by some small distance, say 1 or 2 centimeter. So for today's session, will be covering only this much part of the automatic waste segregator design. So next, what can be done is that, so we need another motor to control the motion of this sweeping mechanism. So for that, we can use another motor, servo motor or stepper motor as well. So for that, what we can do is that we can insert another, what do you say, another bar like this from which connects from here to here, and then attach a motor on that, which will attach to this part, and then both of these can rotate independently with two different motors. But we will be covering things up to this part only for this session. So here we have created 4 components. We have also seen one join, and the new thing which is there is how can we import some designs directly into our workspace. So some motors or gears, for example, or screws, which are standard things, you can find those on the internet, download it, load it into Fusion 360, save them, and then you can directly import them into your designs. So I think this is it for today's session, the Fusion 360 part. I will stop sharing my screen. Okay, so are there any doubts from anyone about the entire session today? Anything? And also put it in the chat if you want. So also there will be a task related to this session. So you have to make some model in Fusion 360. So that model will be the crank slider mechanism which I had shown just to illustrate the joints. So we will be sending out the official task on the group, but the task will be you have to create this crank slider mechanism. And so for that you will have to create the different components and then assemble those together with joints. So that will be the task, and I will be also sending some reference link in case you get stuck or you need something as a reference and you cannot do it on your own. So you can follow those videos and submit the in the format which we will specify. So if there aren't any doubts, maybe we can end the session for today. And from next time, we will be starting the electrical module. So in that, we will be covering different types of motors, different types of sensors, Arduino, programming with Arduino, and some of the aspects of electronics which were used in this project. So from next time, we will be starting with the electronics module. So the mechanical module has been completed today, and again emphasizing the point that Fusion 360 is just most of the learning in Fusion 360 is exploring on your own, trying out new things, and just searching it up on the net if you get stuck. So that's why we don't have a lot of content in Fusion 360, because you can go on showing many designs, but it's of no use until and unless you go and actually try and start making something on your own. That is it about today's session. So I think if there are no doubts, then we can close the session for today. Okay then, thank you guys. We will be meeting next on Thursday, which is 14th of July for the electronics module.
Thank you.
Thank you.
Yeah, bye.
Bye.